Okay, so we were working on this problem this morning, and it said you had a 3x3 grid, and you colored each square white or black, and then you rotated around the center, the whole square, and you changed all the white squares that were now on a black square into black squares, right?
Yeah.
And it asks, what is the probability?
I think it was white squares that moved into a spot that the black square was on.
Oh yeah, sorry, that's what I thought that had previously been black.
Yeah.
Right? And it asks, what is the probability that after that operation all the squares are black? And what are some things that we learned this morning?
Well, we learned that there were 9 cases.
Okay.
So this is the number of black squares.
Yeah, you don't need to write them on.
So 0 out of 9 through 9 out of 9.
Okay.
And we learned that there's some symmetry in this.
Okay.
Like these 2 cases are the same, or they're not the same, but they have the same number of elements.
Right. Okay. Good.
And we learned that for it to not work, you have to have a white square starting in the center.
Okay. If you have a white square starting in the center, it definitely will not work. Okay. So what do we need for it to work?
Well, we need for a white square not to be in the center.
Okay.
And this to be black.
All right. All right. Good. Right. Use mine right there. All right. Well, good. So, but we got to a point this morning that seemed like it was going to be pretty difficult. We had to look at the 5, 6, 7, 8, and 9 cases from your other cases.
5 out of 9.
Yeah. So I kind of want to start over. And see if there's something else we can look at. And you mentioned something that you saw in the numbers, which was some symmetry in the numbers. So let's see, symmetry is a key idea in solving this problem, but not in the numbers, but actually in the patterns. So let's talk about some things that you see in the rotations of the square.
Alright.
What are some things you notice in the rotations of the square?
Well, you're rotating it 90 degrees clockwise.
Yep, you rotate it 90 degrees clockwise.
So, well, a bunch of edges, like, so this corner goes to here.
Okay.
This edge goes to here.
Yeah.
And this happens.
Okay. So how could you describe what's going on there?
Well, like this side becomes this side.
Okay.
And this side becomes this side.
Yep. Anything else you notice? Just simple things about the rotations.
Well, edges go to edges and corners go to corners.
Edges go to edges. Corners go to corners. So you're calling these middle pieces edges.
Yeah, these are edges.
Okay. Edges go to edges and corners go to corners. Okay. That's a really important idea in this problem, and that helps us simplify what we're looking at tremendously, because the edges don't affect the corners, and the corners don't affect the edges.
Well, you need, for them to both be black, you need 2 of the corners to be black.
Okay.
So, and they have to be diagonal from each other.
All right, cool.
And 2 of the edges need to be black, and they have to be diagonal from each other. Well, across from each other.
Let's start talking about the corners first. Let's not jump ahead. Let's figure out the arrangements that the corners can make for our square to turn completely black.
Well, you can do this one.
Okay.
Or you could do this one, where they're here and here.
Okay.
And flipping them doesn't matter since the squares are all identical.
All right.
So there would be 2 arrangements.
Okay.
With the corners. Because you can't like go here and here, because then you don't get this square.
All right.
So 2 for the corners. Is there any more?
a good question to ask.
Well, you can't. I don't think so because you have to put it directly opposite it. If you put it here, you're gonna miss a square. But you could also have 3. You could have 3 black on the corner.
All right.
So, like this.
Okay.
And then this one could go anywhere, here or here.
All right.
This is gonna get complicated fast.
Well, it's still a lot less complicated than it was over there, what we're looking at this morning. So let's see if you can find a systematic way to count the number of corner arrangements.
I'm gonna have the ones that are opposite each other on these corners.
Okay.
And then this one can go here or here.
All right.
Or you can have 2 or none. So
Keep going.
you could have, as you don't need these, you could have just these 2. You could have this one being here or here.
Okay.
And then you could have both. So that would be 4 arrangements.
So we've gone over 5 minutes. Go to the next movie.